In this video, we're going to continue topic 4.5. In this particular set of videos, we're going to work on solving equations by completing quadratic equations by completing the square. We're going to use our complex number system, which means that we're going to have some solutions that are non-real. All right, so before we start doing completing the square, there's some steps that we typically use when we go through completing the square. So I'm going to write those steps out in the left-hand column here. The first thing we're going to do is we're going to divide by the leading coefficient. Remember, that's the number in front of x squared. And then we're going to subtract the constant from both sides. And when we do that, we add in plus blank. And then we're going to divide the middle by 2. Let's divide middle term by 2. And then you're going to square it. That is where the completing the square part comes in. And then you're going to solve or simplify. So let's go ahead and try this first one together. So the first thing I notice is that I do have a leading coefficient. So I am going to go ahead and divide everything by every term by that leading coefficient. So I'm going to divide everything by 3. That gives me x squared plus 3x minus 2 equals 0. Now I'm going to add this third term, this constant. Technically, we're subtracting, but we're adding a negative to both sides. So we're going to add 2 to both sides. So we've got x squared plus 3x equals 2. Notice I left some space because here we're going to add in a plus blank. Because whatever I do to the left side, I also have to do to the right side. Now I'm going to set up what I call cheating factoring, and I'll show you why here in a minute, but it gives me a nice placeholder space as I'm dividing the middle term by 2 as a place to keep it. Okay, and of course they gave us one that's ugly to begin with. So I'm going to start by putting in x here always. So it's kind of the skeleton of what I would get when I factor. So I'm going to divide this by 2. When I divide that by 2, I get 3/2. And then I'm going to square that. That's kind of my hint right there, to square it. I'm going to square it. I would get 9/4. And I'm going to add that 9/4 to both sides. I'm going to work a little bit smarter on the right side. I'm going to turn that 2 into an 8/4, because that's another name for 2, and then I have a common denominator. 8/4 plus 9/4 is 17/4. All right, I'm going to pause on the problem for a minute and help you understand this piece right here and why I did what I did. So really to get from this line to the next line, what I really need to do is take this piece here and do a magic X. So I would need 2 numbers that multiply to 9/4 and add to 3. Well, that's ugly in this case. It would be 3/2 and 3/2 would multiply to 9/4 and would add, because 3/2 plus 3/2 would be 6/2, which would add to 3. So I set up what I call cheating factoring, because whatever you get in here is what you get with the middle term divided by 2 and then square it to get back to that value. So it's a little bit of a shortcut. All right, now I'm going to solve by the square roots method. All right, so I'm going to undo the square by taking the square root of both sides. I'm going to put a plus minus in front. We've got x plus 3/2 equals plus or minus. I know I can't take the square root of 17 nicely or even break it up, but I can take the square root of 4 is 2. And good news, I ended up with the same common denominator. I'm going to subtract the 3/2 from both sides. So I end up with x equals negative 3/2 plus or minus square root of 17 over 2. Or another way to write that would be negative 3 plus or minus square root of 17 over 2. I like the look of this better, but sometimes they do that. So they're both 100% correct answers. Notice we didn't get any I's. And the plus and minus takes care of two solutions. So we have two real solutions because they did ask us about whether they're real or non-real.